Thank you very much. I appreciate that. Okay, so it's not unlikely that you'll see a question on the GED test that says something like, what number makes the following undefined? When you see this, your clue is, oh, that means they're trying to divide by 0. So if they have something like this is it. So what number makes this undefined? We go, oh, we want to somehow get 0 in the denominator. To make this thing equal to 0, it equals 0 when x equals 9. Okay. So I am positive that there are lessons in KET that give you some practice on this idea of undefined denominator. So do all your KET lessons that I assign, and that way you'll find some more practice on this. Or you could ask me for some more practice and I'll dig some up for you. All right, so with that, I'd like to start on today's practice, which looks like this. This is page 17 in your workbook. And now we're going to be solving equations. So everything that all of these problems today will have an equal sign in it, and you'll be able to find a number that makes this statement true. On this worksheet, the first problem on each row is worked out for you the way that I like to work it. There are other ways to solve these. If you have a different method that you're used to and comfortable with for solving these, continue to use your own method. For some of these, you should just be able to look at that and just already know what the answer is without doing any work. And if you can just write down the answer, that's okay with me. As you go down the rows, the questions get a little bit more complex. And so if the first row just looks way too easy, go ahead and work at least one problem in the first row, but you can skip through any that just look way too easy for you, because there are lots of practice problems here. The second side is on subtraction. Now, I believe that every one of the students that's online right now has worked these kinds of problems successfully. So, except everybody always complains about the fraction ones. But I'm going to give you a couple minutes to work through these just to kind of warm up. And when you're ready, if you want to check answers, let me know. I'll dig up the answer key for you. Interesting. Hmm. Okay. Is anybody working or are you all making coffee? Oh no.
I'm doing the problems.
Oh, you're a good boy. And Kevin, did you finish your test yet?
No, I've been doing other things. I need to be focusing on that more though.
You do. You just want to do a GED ready?
Yes, GD
Did,
readies are awesome.
did I send you a voucher, Kevin?
I think I still have one
Oh,
that
good.
I haven't done yet that I activated that you gave me. So I
Okay.
could try to do that today.
Oh,
Also,
I I think that might be better because we're not getting the other stuff done. So we might as well just go to a GED ready.
yeah.
I think it'll I think it'll narrow down what you need to study.
Oh well, I trust those tests too.
I do too. Definitely. Okay.
Could I ask you a question on the third row?
Yes, the third row. Let me get my camera.
Third row, last question. So I don't know if it shows you about my calculator there. Say I just type it in exactly how it is, right?
Oh, yeah.
It would give me a different answer than just logically looking at it and be like, oh, you need to add.
Okay. Which one are you looking at?
The last one on the third row?
This one. Oh yeah, the big mess. Okay.
Oh, actually, okay. Yeah, so you would just do the same thing, just the minus the fraction, right?
Yep. Well, you have to subtract, but this is actually a mixed number.
Mm-hmm.
So, yep. And then,
So
do you need to know how to do this in your calculator?
it's the second button, right? You press the second and then.
Uh-huh. Yeah.
Ooh, okay, my bad. No, just looking at it again, I think I figured it out. I thought those both were the same fractions.
Oh, okay. Nope. Little difference there.
Yeah, okay.
Okay.
Mary, can you send the answer key, please?
I can, except you're not going to like it. I just looked at the answer key and it has all the answers for the addition page. And the subtraction page is completely and thoroughly blank. I don't know what happened. So I'll send you answers to addition. Then I'm going to have to go to work and fix the subtraction page.
Okay.
Or I can send that to you. Okay, I'll send that right now. Touch. Okay, should we, oh, yeah, and I'll give you a chance to at least look over your addition answers, Lynn. Joe, are you ready for answers or?
Yeah, I'm good.
Send those to you too. Okay. Are you ready for some new information?
Yeah.
Yes. Okay. All right. So I'm going to try to address a question that I get every single time I teach someone algebra. And we'll see if I can get it right this time. So if we have a problem like this, this is a subtraction problem, but whenever we do algebra, to solve it, we end up doing inverse operations. We end up doing the opposite. So to solve a subtraction problem, we have to add 15. And I guess the way it's usually explained is what we're trying to do is get this thing into a form where it has X on one side and just a plain old number on the other side. And that way we'll know the value for X. Here, the issue that we have here is that we have subtract 15 on the same side with X. And I wish subtract 15 wasn't there. And the way I can make subtract 15 go away is to do the opposite of subtract 15, which would be add 15. But since this is an equation, we want to keep it equal on both sides. If I add 15 to this side, I better make this one 15 bigger also. These cancel out. 4 and 15 is 19. And we end up that X equals 19. And then we could go back and check and see if this is a correct answer by substituting this value 19 for this symbol every place where it appears in the original equation. So 19 subtract 15 does equal 4. So if we have an equation like this one, this is a multiplication equation. I wish X wasn't multiplied by 7. If it was all by itself, I'd know what it equals. So I want to unmultiply it, or the opposite of multiplication is division. But I have to do that on the other side also. These cancel out, and I end up with X equals 63 divided by 7, which is 9.
Yep.
Yes, 9. Okay. So easy enough. it's a multiplication equation, you do division to solve it. Now, and I could show you an example of an addition equation or a multiplication or a division, I could show you addition or division and we'd find the same thing. You do the opposite to solve. Here's where students get confused. And that happens when you have some sort of an equation that has two or more operations in it, like this one. Okay, this equation has addition here and it has multiplication here. So I know I'm going to have to subtract and I know I'm going to have to divide. What do I do first? And the what do I do first is the question that I always get from students when I'm teaching them algebra.
Well, multiplication is going to be the first step, right?
And no, actually, it turns out to be the second. Well, it turns out,
Oh, I got you.
as it
Okay.
turns out, we usually
Does
end up,
PEMDAS even work with some algebra? Like with most algebra, I don't think it does. Does it?
PEMDAS tells us how to deal with stuff that's all on one side of the equation.
Oh, okay.
Oh.
PEMDAS doesn't help us solve equations. And so that's where the confusion comes in.
Okay. So what you've taught us so far, you would take 37 minus 7.
Yeah. Yeah. Some general rules about equations, and it's really, if I could just list all the rules for solving equations, I would. But we don't have rules for that because every situation is a little bit different. Once you've worked a billion equations like I have, I just, most of them I can just look at them and I can tell what step to take first. But in general, if you have multiplication and addition, you want to get rid of the addition first. So with the types of equations that we're going to be working today, you're going to want to subtract, or if we had an equation like this, we would want to add first. So I'm going to subtract first. This goes away. And here's a hard and fast rule that I can give you. If you try something and you end up with something that looks more complicated than what you started with, you probably did the wrong step first. Try something else. This is definitely, it makes it much simpler. Now we just have one step to solve. It's multiplication, so I have to divide. Let's do another one. Okay. This one has subtraction and multiplication. We're going to want to get rid of the subtraction first. So we're going to add. Oh, that made it much easier. So now all that's left is to divide by 3. Let me show you what would happen if somebody says, same problem. I want to divide first. I insist on dividing first. So in this case, we divide by 3. But you have to divide everything by 3. This was supposed to say equals here. So not only both sides, but every single term has to be divided by 3. Well, that makes this one nice. Well, actually, this isn't too bad. Now I just have a subtraction equation, and I would solve it by adding. I want to add 28/3 plus 8/3. Oh my gosh, let's see what the calculator does with that. Oh my, we got the same answer. So, I decided I was going to do division first, and that's actually a legal move as long as you do everything, as long as you don't make any mistakes, you're going to come out with the same answer. But
What? No way.
which was easier, method number 1 or method number 2? Well, basically, this would ended up with a whole bunch of weird fraction stuff that I had to deal with. So I think this method is easier. And so anyway, that's why I teach people, do the addition or the subtraction first. All right, so let's try another one. I'm going to add just a little bit of complexity to it. Okay, here we go. Ooh. This one looks like it has subtraction, addition, multiplication, and multiplication. And look, it has the variable on both sides. Oh my gosh, does it get worse than this? And so if I said do addition or subtraction first, but ones that are even more complicated, there's something you should do before the first thing.
So you're watching TV and I was carrying it like this, and just like hit the bottle, like clink, and he looked back. So I was like, oh.
So if you have the variable appearing in more than one term on the same side of the equation, you want to combine like terms first. And like terms are going to be terms that are multiplied by the same variable to the same power. So these things can be combined. 3x subtract 6x is negative 3x. So this is definitely a little bit simpler than that. still have the issue of the variable on both sides. And I want to clean that up before I start doing any multiplication or division. This one, it's going to be easiest if I add 3 times x to both sides. That makes this one go away. And then that leaves me with 2 equals. So -4 plus 3 gives me negative x. Oh, and then I have to explain this thing. I don't want to know what negative x is. I want to know what x is. So I had to get rid of the negative. I actually have to do a multiplication here. I'm going to multiply by -1. A negative times a negative is a positive. Any number times 1 is just itself. So now this gives me positive x, and -1 times 2 is -2. Now, let me take a step back and see if I can find another. I'm looking for problems out of the book. I'm going to look for a problem that has some of this idea in it, but maybe not all of them at once. Yeah, here's a good one. Subtraction, addition, multiplication, multiplication. But I can see that there are 2 terms that are like terms, and I'm going to combine that first. So 2x subtract 5x is -3x. Still have the plus 11 equals 38. Now all I have left is a multiplication and an addition. I'm going to take care of getting rid of the addition first before I'm going to get rid of the multiplication. And now all that's left is to divide by -3. X equals -9. Let's look at another one here. So for this one, we have the variable on both sides of the equation. And we also have plain old numbers, also called constants, on both sides of the equation. We have addition, we have subtraction, and we have multiplication. So what should we do first? And the answer is, the very best answer is,
Combine.
yeah, let's subtract 9x from both sides. When you have the variable on both sides of the equation, you're going to have to do something to get rid of the variable on one side of the equation. And it's good to do that first. Always just bring down the other terms with their sign. So we bring this down, we're going to bring down the sign, the negative 32. See, it was subtract up there and now it's negative because they're the same thing. Sorta. Okay, now we have addition and multiplication left, and we should take care of the addition. Negative 32 minus 12 minus 44. Now there's only multiplication. So let's see who is still on. Okay. Kevin, I know that these problems they're just about the right level for you. You get it right most of the time.
I like watching you work these. It
Do
helps
you?
remind me too.
Yeah. Joe, have you done these kinds of equations that have multiple steps in them?
It's been a while, so I mean, I'm getting them down for sure.
Okay.
Yeah, I definitely kind of just like to see what you do because I got 44 as well. But then also I question myself if I did it right, if I just minus 12, then that would have been 10. So I just question the way I would have worked it. But
Right. And with this problem, again, there are many, many different ways that you could work it. And they're not wrong. Let me show you a different way to do this. It's just as good. Now, what did we do? So we subtracted the 9x. Gosh, somebody else could have said, well, I don't like subtraction. I'm getting rid of the 32 right now. That looks pretty good, doesn't it? But we still have this issue. And there's many different things that we could do at this point, but the only thing that makes sense to do is to subtract 11x from both sides.
Why don't you subtract 9x from 11x?
All right, let's do that.
So it'd be 2x, right?
Yeah.
So 2x plus 44 equals,
Wait, oh, yeah. Sorry. 2x plus 44 equals, what is this equal?
9x.
No, I had to subtract 9x from there.
Oh, so 0.
0. Okay, that's okay.
That's an answer?
No, we have to get x all by itself. So
Oh,
we
that's right.
have some more steps. What's the next step now?
Let's go
Minus
in.
40.
Multiply.
Minus 46.
By 2. Oh, no.
Yeah, let's subtract the 44 at this point.
So negative equals negative 44. 2x equals negative 44.
Right.
4. Then you
And-
divide by
And then
2.
you divide.
And by 2,
Mhm.
and you get that x equals,
22.
oh,
Right.
and we keep getting the same answer.
Yeah, that's cool. I like
But if-
these. They're fun.
Yeah, and this way wasn't a bad method at all for solving it. We
But
didn't.
this way, Mary, this way it seems like it's a little longer than the other one, if I'm not mistaken. Is that what it seems like?
Yeah, I think it was one extra.
Yeah.
Yeah, but it all comes to the
I-
same answer. So it doesn't
Yeah.
matter how you
It all
do
comes to the same thing. You want to see some real magic? Might as well show.
No.
If we started with this right here,
Yeah.
now some people say, "Oh, let's divide by 2."
Yeah, because that was my my
Yeah.
thought. Divide.
And
But as long as you divide everything, would it
as long as you have to divide
wouldn't that be correct still?
Yeah, but you have to divide everything by 2. And
Ew.
x, this goes to 22. And what's 0 divided by 2?
0?
0. Yeah. Oh, this isn't
Oh, then you'd minus 22 and then blah, 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 blah.
Oh my gosh. So that's not bad at all either. And Lynn, mathematicians, people that have done a lot of mathematics, this is exactly the step that we would have done right then and there. And it's because we know of this magic that happens when you take 0 and divide it by anything, you just get 0. So anyway, that's a situation that mathematicians always look for. And
Shortcut.
it's going to end up being a shortcut. Yeah.
Right on.
Okay. Well, I'm learning a little bit more than, teaching myself, so that's good.
Good. Now, while we're at it, since you guys are up for it, let's do this one. Okay, this is that same problem. Oh, guess what I want to do first? I want to divide by 11. Since it's just,
So
Okay.
everything would be divided by 11.
everything gets divided by. Okay, well that made that easier.
1.01.
Oh yeah, how do we like it so far? Well,
I don't know.
how about
Could we minus 12, 11? Yeah.
what do you want to do? You want to subtract 12 11ths? Let's do that.
Yeah, from 32 11th.
Yep. So negative 32 11ths subtract 12 11ths. Guess what we're going to get?
22.
No, because
Oh.
a negative subtract a negative is like,
Positive. Add. No.
oh wait, you're right. We add it, so we get negative 22. Now wait a minute. Let me see what we get. 32 minus 12. No, it's going to be negative 44.
Nine x over
You
11.
should see the answers I'm getting here. Negative 32 11.
It's definitely negative 44.
It's definitely. Okay. So we get, notice how we keep getting some of the same answers show up. Oh, now what are we going to do? Well, I have to get all the x's. I guess I better subtract 9x from 9x over 11. Oh, how can I do that? Oh, I don't even know how to do that. Yeah, no.
That row.
Actually, I do know how to do it, but what a mess. A big old mess, right? At this
Yeah.
point, really, you know what would make this easier is to multiply everything by 11.
Yeah.
But look, I did that we divided by 11 there, and then I want to multiply it by 11 here to clean things up. This does look a lot better, doesn't it? Anyway, what I guess that works really well most of the time is when you try something like this, and if you end up with a big old mess, just start over and try something else. There are many correct things that you can do to an equation, but some of them make it messier and some of it simplify it. And we want to get it simplified as quickly as possible. You want me to work a couple more while we're on the
Sure.
Yes.
You seem to like, I don't know, personally, for myself, I've learned a lot by watching teachers work problems. So I don't mind doing it.
I tell you though, that reasoning with algebraic pretest, I didn't do too good.
I think I looked at your.
But I think this is kind of like part of it, refreshing the memory.
Yeah, I think it didn't seem that bad to me when I looked at your score. I'll have to look back and see what it is that it thinks you need to practice.
The whole thing.
The whole thing. Yeah, so we'll just keep after it, right?
Yeah, yeah.
Okay, we have multiplication, addition, and subtraction. Kevin, you seem to have a really good sense what to do first that would make it look simpler.
-8 or +8.
So you want a +8 because we hate this subtraction stuff, don't we?
Yeah.
End up with any negative numbers. Okay, so we add 8 to both sides. That makes this one go away. Okay, Kevin, what would you do next?
Maybe divide. Actually, no. -16 on each side. I don't know.
Let's do that.
Now I divide.
By,
5.
you have to divide the thing by 5. So each time we keep having x on both sides of the equation, no matter what we do. What a mess. I don't like it. I didn't mind this step, adding 8 to both sides. Wait. Okay, so at this point, really there's two things that would make perfect sense. But we have x's on both sides of the equation. We want to get x's just on one side of the equation.
We'll probably do 5x.
So do you want to subtract 5x from both sides, Vicki?
No.
Get them on the same side.
That would get all the x's on the same side. If we
Is that a legal move?
to subtract 5x? Yes, it is totally legal.
Legal. Oh my God.
Okay, this thing right here, remember, It really means 1 times x. So we have 1x subtract 5x is going to give us negative 4x.
And then do the 4.
Now we divide by negative 4.
X equals negative.
So that'll be, I want to say positive 4. Oh, negative 4. Huh.
It's negative, yeah, 16
I
divided
need
by
to practice getting variables by themselves on
Yeah.
one side.
Yeah. So, let's make this a rule. Okay, so here's that same problem. Now, to solve this, we had to do a couple of things. We had to get rid, let's see, we had to get all of the constants on one side of the equation, and we had to get all of the variables on the other side of the equation, and then we had to divide by 5. So the one thing that we could have done first off would be just to subtract x from both sides. 5x minus x gives us 4x. Then this looks like, oh, I'm supposed to subtract 8 from both sides. Divide by 4. X equals negative 4.
I like that way better.
Yeah.
Way
So-
easier.
And it, part of that,
So doing the variables first almost seems like a better idea.
it's a good idea. And it was a much better idea for this particular problem. It's always a good idea. Get rid of the variables first. It just, it makes the whole thing look easier too. Okay, so let's try another one where we need to get rid of the variables first. Wait, didn't we already do this one? Oh, it's been so long, I forgot already. Did we do that one? Let's get rid of the variable first.
Oh yeah, I remember doing this. Just
Did
earlier.
we,
Yeah.
we just did this
So,
one?
sorry. Yeah, minus 8x from 11x.
Okay. And now what?
Plus 10. I would just plus 10.
Plus 10.
And then we divide by 3.
5 by 3, yeah. Okay. Oh man, it gets easy when you do it that way.
I'm gonna do the GD ready probably soon eventually. Probably today. I can do it today.
Yeah. Yeah, I think you should do it today.
I will.
Can we do this one? Hey, what do we do first?
Minus 5x from yep. Then minus 6 from each side.
9. Oh, 6.
I mean, then you could divide, but it wouldn't be anything.
Oh, it would be something.
It'd be 0.
No, what's 3 divided by 3?
Oh, 1.
Yeah, that's 1.
I forgot.
Okay. And even if it were 0, 0 is still a very important number, and it will be the answer to some of your equations. Wow. Okay. Let's check and make sure. I haven't been checking answers. I've just been assuming that everything I've done has been perfect today. That always gets me in trouble. But I'll just remind you, we could check and see if this is the correct answer. Every place you see this symbol here, it stands for the number 1 in the original equation. So it would be 8 times 1 plus 6 is supposed to be equal to 5 times 1 plus 9. 8 and 6 is 14. 5 and 9 is 14. So x equals 1 is indeed the correct answer. Wow. Want one more level of difficulty added to this now?
Yes.
Beg for it. No, just kidding. So let's do this. Ooh.
So that'd just basically be like 1. Would that be 2x? And within the
5x
parentheses?
plus 1 would be 5x plus 6.
Oh, Vicky, like what you're thinking. You are so close.
Do you divide it?
Oh,
Does the
So-
answer
or
equal-
the minus, no.
Hmm.
I'm going to say minus the 1 from each side. But then again, I think there's that parentheses. You work the parentheses inside.
Yeah, that parentheses boogers things up, doesn't it?
Parentheses are first, right?
If you're just thinking about one side of the equation,
Mhm.
So
Yeah,
would it be
those
2x?
parentheses, so
5x plus 5.
when we have stuff like this added up inside of parentheses with the number on the outside multiplying.
You distribute.
Distributive
So-
property. Yeah.
Yeah, so it'd be 5 times x, and then it'd be 5 times y. I get it.
So if we choose to use the distributive property here, it would be 5 times x,
It's 5.
5 times 1,
Oh, sick.
and that equals 75. Now, you might be thinking, well, did we make this simpler?
No.
And
5, both
Yeah.
sides?
technically, we did make it simpler because if you, the
Oh.
definition of simplify mathematically, one of the things is get rid of parentheses. So we got rid of the parentheses. We don't need them anymore. So basically, this is simpler. And now this is in this kind of equation.
Oh.
Those, that's easy. What do we do when we have multiplication and addition? What are we going to do first?
Minus
We're-
5.
Yeah, we're going to subtract 5.
And then 70 divided by 5.
And then divide by 5.
And you get 14.
Okay. Now, Billy, you said you wanted to divide.
5 over, oh,
Yeah.
Yeah, all right. Well, let's look at Billy's way of doing this. So, Billy, what would you choose to divide by?
That's 5 divided by 75.
Okay. So this here, 5 times x plus 1, since it's all multiplication, when I divide, this whole thing can be divided by 5, and 5 divided by 5 is 1. 75 divided by 5 comes out to be something.
15.
I can believe. Yeah, okay. So then we have x plus 1 equals 15.
Yeah.
Subtract 1, x equals 14. Oh my gosh. We got the same answer. And in my opinion, Billy, you chose the simplest method to get there.
Yeah.
Yay!
I have to go on a horseback ride trail. I'll see you later, Mary.
Oh, okay.
But I wanted to
have
jump in.
fun, be safe.
Have fun,
so,
be safe. Yeah.
see you guys later.
Okay, bye. So, what if the problem had been something like this? So this is almost the same problem, except now it's 2 times x plus 1 equals 75. It's a different problem, but it's the same format.
Could you do exactly what Billy did?
Let's do exactly what Billy did.
Oh,
Decimal.
It's going to be a decimal, but it's going to be a decimal no matter what way we solve it. The next thing would be to subtract 1. Now, 70, this fraction, subtract 1, is going to come out to something. I think it's out to be 71. Let's see if it does. Yes, 73. How did I get 70?
because
Oh,
that
I know why I did.
75. So this is the same answer that we would get if we did it the other way. Let me show you that. So if I start with 2 times x plus 1, 75, it would be 2x plus 2 equals 75. Then we'd subtract 2. 2x equals 73. Divide by 2. X equals 36 and a half. Same answer. The only difference up here, when Billy said, oh, let's divide by 5, I was going, woo-hoo, because I already know that 75 divided by 5 is going to give me a whole number. So I knew that it was going to make this equation look really simple. Down here, when we divide everything by 2, I knew we were going to end up with a fraction or a decimal. So it's not as obviously helpful to just divide. Yeah. So that was a lot. And I don't know if I did the right thing by showing you that trick or not. Okay, let's see who else is still here. Vicky now too. Trying to keep track of attendance here. Okay, let me say this about my math class. Every time I've taught this math class, when we get to algebra, I always find that there are some students who are always really, really good at it and need very little help. And there will always be a few students that are just learning algebra, and it all sounds magical and wonderful to them, but they just need more practice and more help with it. So I'm totally comfortable with having the class be all over the place, but I've never had to do it online before. When I'm in the classroom with you, I can walk around and I can see what kinds of problems you're working on and where your issues are. With you and this situation we're in now, I'm going to have to trust you to check your own work and to tell me what things you're having trouble with so that I can help you individually. And I believe that some of you will need some tutoring, and some of you will just want to get offline and get on to some challenging work on your own. So we can do all of that this week, okay? But you have to let me know. And the other thing that I want to show you is the schedule. Let's see if I can bring it up. Yes. Okay, so I think you can see my screen now. It's kind of small. Let's see if I can make it bigger. Can that way? Probably do it. I don't know. We are in week 4, so we're right in that middle week of a 7-week session, and we'll meet all 5 days this week. I had on the schedule just to do 1 variable equations today, which is what we did. But we did multi-step equations today, which I had on the schedule for tomorrow. So it means that we're right on schedule, even though we kind of missed a couple topics last week. I have tons and tons of worksheets, a lot of different practice for all different levels that you need. So today, I think I'll send out some worksheets today, and that's what I'd rather do. I'd rather just go ahead and assign the KET lessons, and then tomorrow we can decide, each of you can decide individually with my help what areas you need most practice in, and I'll load you up with worksheets just in your own areas. So it looks like the KET lesson for today is in the algebraic reasoning section, and it's lesson 3.1.
3.1.
3.1. That's it. All right. So any other questions?
No.
I'm gonna get on my GED ready thing, probably.
Oh, all right. You do your GED ready, Kevin. I'm excited for you. I think you're ready for it. I really do.
Well, I took one in math before, and it wasn't that bad of a score.
That's what I'm
It
remembering.
was like a 130 something.
Uh-huh.
So like, I don't know.
I recall it
That was a long time ago, though. That was a
It was a
long
long time ago, and it was pretty darn close. And I bet that you're going to get even close.
And like, cause I had a lot of math classes, way after that I attended,
And I just bet if you have the sit down and work it, without interruptions. And
it's like 40 questions, right?
I think it's fewer than that, Kevin. I think it's.
Well, I remember what the other GED readies were like, and how many questions were on the other ones. I don't know if it's kind of similar to how many questions would be on other subjects.
It's, I think, a lot of, well, yeah, I'm just not sure. With the language arts question, they usually make you read through a few pages before you ever.
Oh my God, it took so long.
I can't ask you that many. But the GED ready test is designed to take 45 minutes. So it won't take you forever. Just a little piece of your afternoon. Okay. All right. So anybody else with questions or comments before we go?
Nope. Well, not right now.
Not yet. Okay. So I'll have my phone with me most of the day today. Shoot me pictures if you have questions of anything. Okay. And
Okay, sounds good. You take care.
I'll probably answer you back today. Okay.
All righty.
Have a good day.
Bye.
Okay, thanks. Bye. I'm gonna stop.